Alright, welcome to part 3. On this one, we've got the cube root of negative 27 x to the 9th. So what makes this one a little bit more interesting is we're going to start putting in some of the variables. Well, you just think of it in sections. The cube root of negative 27 is negative 3. And there are 9 x's here, and I need to put them in groups of 3. So I'm asking myself, how many groups of 3 are there? It's a division problem. 3 goes into 9 3 times. And that is your final answer. So on the next one, I've got the 8th root of 8y to the 16. Well, there is no 8th root of 8. I think they're trying to trick you into thinking, well, 8 divided by 8 is 1. Don't fall for that trick. There's no whole number times itself 8 times that equals 8. So I'm going to leave that 8th root of 8 underneath the radical. Now I'm going to look at my variable. 8 goes into 16 2 times. Technically, we should have absolute values around those. We're not going to worry so much about that in this course right now. On the third example, I've got the square root of 20. And if I do a factor tree on that real quick, it's a square root. My index is 2. If I simplify the square root of 20, it's 2 radical 5. So I'm going to have a 2 on the outside and a 5 underneath. Now I want to look at my variables. As I said, my index is 2. 2 goes into 16 8 times. And on our last one, I'm going to have a to the 3rd, because 4 goes into 12 3 times evenly. 4 goes into 9 2 times, but you're going to have 1 left over, and that leftover one has to stay in the radical. And don't forget to write your index. On our next example, I know it's a little hard to read, so I'm going to rewrite that. B to the 5/4. Oops, getting ahead of myself again. B to the 5/4 times B to the 3/4 all over B to the 1/4. Well, I'm multiplying the numerators, so it's going to be B to the 5/4 times 3/4. Well, I'm timing, so I need to add my exponents. And that's going to give me B to the 8/4 over B to the 1/4. Well, that means division, and for division, I subtract my exponents. I'm going to have to subtract 1/4, and I'm going to get B to the 7/4. On the next one, I need to figure out the 6th root of 640 off to the side. Let's do a factor tree, and that's going to be 64 times 10. 64 is 8 times 8, which is 4 times 2. And the 4 is going to be broken down some more. And 10 is just 2 and 5. Well, what I notice is that is a 6th root, so that means that they need to be in groups of 6. But out of a group, only one makes it out. That 2 and 5 don't have anybody to pair up with, so it's going to stay under the radical. Now, don't forget my index. Now I need to look at my variable 3. 6 does not go into 3, so it has to stay under the radical. All right, on this last one, it looks complicated. It's not. There's a couple little tricks, though. Got the 5th root of 4. You have to recognize that you can write those with the same base. 16 is the same as 2 to the 4th. 4 can be written as 2 squared. So that's really going to be the cube root of 2 to the 4th and the 5th root of 2 squared. Well, I now have the same base. Let's write them as a rational exponent. So that's going to be 2 to the 4/3 over 2 to the 2/5. They have the same base, and I'm dividing, which means I subtract. So it's going to be 2 to the 4/3 minus 2/5. I need to get a common denominator. My common denominator is going to be 15. So 2, multiply that by 5 over 5. Multiply the second fraction by 3 over 3. That's where the 6 comes from. Now you can just subtract, and you're going to get 2 to the 14 over 15. And that is your final answer. All right, good luck with the homework.